Hello, my name is Barry Epley with Powell Industries here in Houston, Texas. Thank you for joining us today. Let's get started. Today we're going to talk about our journey through the evaluation of Autodesk offering of TruNest, the metrics and the process we utilize to evaluate its software, and why we decided to do what we did. We'll talk a little bit more about who we are as a manufacturer, where our factories are located and why that's important. We'll talk a little bit about our current digital footprint and why we needed to change the dynamic nesting software we did after over 20 years of service. We'll share a little bit about some of the daily issues that we were facing, not only from a process standpoint, but from a support standpoint. The metrics we identified and to create and measure not only our current process today, but also the future state implementation of TruNest, as well as a brief inclusion of some of the issues that we hope to resolve with TruNest implementation. We'll look at some of the various points that we discussed on how we felt TruNest needed to fit within our environment. We'll talk about some of the ROI and why Project TruNest was given the green light to a phased approach. We'll talk about how we eliminated risk for our fabrication process through our first operations. And when implementing a whole new system, what could possibly go wrong? Where are we at with our implementation today? What are our next steps? And how do we feel this project is going? I'm the lead manufacturing analyst for Powell Industries, headquartered here in Houston, Texas. I've been working in the manufacturing space for over 10 years with various types of metal cutting, metal forming, copper punching, welding, robotic welding, different forms of dynamic nesting software. In my free time, I enjoy volunteering as a firefighter, and when I'm not doing that, I'm on my sailboat on the water. If you guys need to reach me for further conversation or to answer any questions after this segment today, by all means, feel free to reach me at barry.epley@powellind.com. Powell Industries, we are a strategic supplier of highly complex and integrated systems for distribution and control of electrical energy. We build various forms of metal switchgear, motor control, bus duct, utility switches. We implement and integrate electrical equipment enclosures, offshore modules, controls and monitoring systems, energy management systems, and process control. We are headquartered here in Houston, Texas, and we do have 6 fabrication and assembly facilities throughout the UK, Canada, and the United Kingdom. On your screen, you'll see pictured one of the offshore modules we've developed for one of the offshore power oil rigs. We currently utilize 3 different dynamic nesting software through our fabrication machines and divisions. Some of our nesting software include ERT copper punches, Trump lasers and combis, Amadas, Koike plasmas, and even an Omax water jet. We are an engineer-to-order company with over 9.4 million parts in our PLM. Our engineering teams publish, on average, 800 new parts a day to the various business systems supporting our shop floor. We use a hybrid of custom, standard, and SaaS solutions and a very complex integrated footprint for our global footprint. Our initiatives are design anywhere, build anywhere. Our nesting softwares are highly integrated into our Oracle ERP and custom MES solution for work order management, raw material inventory control, material consumption, and resource labor charging for our machine rates. We have a custom solution for routing generation of parts through our various shop, spatial, and divisional capabilities and part attribute variables. Basically what that means is I'll take a single part, all the variables about what's going to require to make that part. Each division may have a different process to make that part. And instead of manually creating a routing for each division, we've automated that entire process to output the routing we need for those individual divisions. Currently, 2 of our dynamic nesting software attempt to auto-tool any of the new parts that are published or revised through a custom process in our library process today as they're released. That's what you see on your screen there is the flow rate for the custom process for the library. The other software doesn't have any auto batching at all. It requires every part to be manually tooled. Some of the struggles that we have today is our library process, even after years of refinement, our first pass rate will vary from 65 to 84% on average. We deal with varying quality outputs from our engineering teams. We deal with production impacts due to the backlog of parts being required to be manually tooled. We deal with nesting errors due to tooling configuration changes. We'll get into a little bit of that in a minute. Multi-material nesting and utilization challenges. Our part mix and demand will vary from project to project, so capacity planning can be a little bit tricky. We do all dynamic nesting. We don't do any kind of standard template, standard nest punching, anything of that nature. Some of the things that you'll see on your screen that we measure today is how many errors have we dealt with? What are those errors and what are the breakdowns? What are the trends of some of the outputs and things that we may see? What are some of the different levels of material that we may nest in a single day? Look at that over date ranges. We certainly take a look at what are our current utilizations for some of the different materials that we have, even based on sheet size. We look at the outputs from machines. So how many square inches of material did we cut or form that day? How many parts were punched? What were the weight of all those punch parts, so we can understand how big or how small parts went through the shop that day. We'll take a look at the outputs by part, by machine, by division, to be able to see how do we measure up and how can we get more throughput out of our machines. We worked with Majestic Technologies, an Autodesk partner for the TruNest project. We worked with these guys to talk a whole lot around, what was the post-creation and the tooling UI look like? What is the nesting client? So for us, it's important, being a global company, is it a local client install? Is it something we can install on a centralized server? Is it something we can install on a localized server? It was important to us to be able to understand from a throughput perspective, how can we better increase our throughput and speeds on our nesting cycles based on some of the issues that we've had with internet and network. We also wanted to talk about how can we make sure that our end user roles are built, be able to make sure that operators can do what operators need to do, planners have all the capabilities that they need, and even our manufacturing engineers can do more than the others. We wanted to make sure that, did it have reporting already on board? And if not, could it integrate into our BI tool? Metrics for us are very important. We wanted to be able to make sure that we could continue not only reporting what we're reporting today, but there's some additional metrics that we wanted to be able to develop moving forward as well. So one of the things that we deal with today as well is we struggle with engineer and some of the outputs that we may see when it comes to internal and external contours, complete. Sometimes it's a quality issue. And we want to be able to get that automated back to the engineer, not wait for a tooler to identify what the issue may be and send that back to the engineer. But as soon as the engineer publishes a part, get that direct feedback to them so they can resolve that error before it ever hits the shop floor. We talked to them a little bit about material management, our work order management, the requirements for integration into our ERP. As we've discussed, being able to scale globally, as we scale globally ourselves as a company, is very, very important to us. And also, we wanted to talk to them a little bit about what are the nesting capabilities out of the box for TruNest versus some of the things we were seeing that we wanted to do with our current nesting softwares that was going to incur a lot of heavy additional costs and development to be able to achieve what we wanted to be able to achieve. One of the things that we liked is we could release TruNest in parallel and not have to change anything about our environment today. Our nesting solutions today are very integrated into our MES. And for a reduction in risk, we want to be able to bring up TruNest in its own independent client in parallel. So if we happen to have something go wrong at go live, which never happens, we wanted to be able to make sure that we could just pick up with our current nesting software and not impact our production. One of the greatest things we found when we first met Majestic was one of our dynamic nesting softwares, and the main one that we use, they've been moving people away from that software for over 15 years. Day one of our discussion with them about TruNest, they started naming off, let me guess, you're having issues with this, and you're having issues with this, and you struggle here and here and here. I couldn't even get a word in because they were already telling me everything that they knew, and it ended up being all off of my top 10. So that was one of the greatest comforts, was they already knew the struggles that we had, and they could show us exactly how they could fix those. One of the great things is we can reduce a lot of our technical debt because TruNest does not have the file structure that some of our other dynamic nesting software does. One of the issues to share with you is recently we had 2 of our Vipros machines at our Houston facility down for over 2 days due to a file issue. With TruNest, that wouldn't have happened. Another great thing is TruNest immediately reduces the scrap due to parts being changed during the nesting creation. Uses the latest part revision and DXF file to create the nest, and will immediately remove all potential for creating an old part on a new drawing. So we had struggled from time to time where one of our dynamic nesting softwares, it only checked that we had a program. It didn't check the revision to that program. It only checked that it had a program. So if we released a new revision and it went through our auto tooling process and errored, When we attempted to go and create that nest, as long as it saw a program, it would run that program. It wasn't until further down our fabrication process that an operator would identify this is the wrong revision on the part. We would have to scrap that and remake it and start all over. Think of the costs and impacts there alone. One of the other great things is, regardless of what facility and what nesting software we use at those facilities today, we didn't have to change anything about our nesting process to be able to bring TruNest on board. We could get everybody under the same umbrella, utilizing the same practices. So from a custom footprint, we were going from 3 different softwares to 1. From a technical debt software, we're taking all those different files and file structures and going down to something that significantly reduced the technical debt we would have to implement this new system. As we shared a minute ago, TruNest has its own UI. That's great because despite any future of we may want to change our MES or we may want to implement something new outside of the MES that we have today, there's no custom integration required. TruNest has its own UI and interface with our ERP and can be deployed at any time on any machine. Again, that can be deployed on a local machine for nesting. It can be deployed on a divisional file server, or it can be deployed on a central server for all divisions to be able to use at the same time. One of the other great things that we really liked about TruNest is we can make tooling changes today and it will be instantly implemented on the next nest, where one of the biggest struggles we have with one of our softwares today is it won't be uncommon for us to have 60 to 500,000 parts on some of the various posts that we have already tooled. So if I go to make a tooling change or a configuration change or a parameter change, all of those parts that were impacted by that change would have to all be retooled. Now, as we shared before, some of our first pass rates can be 65% to 84%. So if you're reprocessing 250,000 parts and you have an 84% first pass rate, all of those that erred now have to be manually tooled, again, which leads to nesting errors and impacts to production time. So being able to make a parameter change today or a tool change today and change the next nest and not have to reprocess all those parts significantly reduced not only our processing for manually tooling parts, but also support for reprocessing all those parts by thousands of hours. One of the other great things that we were looking for is TruNest has a verification process built into it. As shared a minute ago, we deal with sometimes engineering quality checks. We have junior engineers just like everybody else. We may deal with an external contour, an X and Y may cross, or it may not complete or close. And an internal geometry isn't quite closed. Through the tooling process, that will just simply error. With AutoTran built into TruNest, it will not only error, but it will identify the error in a direct plot, and it will communicate that directly back to the engineer that just published the part. So instead of being 2 weeks down the road and impacting our production at that point in time, the engineer is able to identify or see the error that they just published, resolve that part, republish it, and have it tooled before it ever impacts production. Another thing that we struggle with today, with some of our machines outputting 6,000 to 10,000 parts per day, our bottleneck within the fabrication process are all those material handlers on the backside of the machine, breaking out those parts from those skeletons, using paper drawings to be able to identify which part is which, separating all of that out, and sending it down the fabrication process. For us, we tried to implement etching with the software that we had in place today, but it was all manual to be able to make sure that we didn't write over any type of internal geometry, to make sure that the etching scaled to the size of the part. With TruNest out of the box, that etching and dot plotting for even some of our custom copper processes was all out of the box. No manual impact at all. The other great thing we like is the impacts of Autodesk University. Anytime there was a new rollout to functionality or we wanted to bring a new operator on board, we wanted to make sure that we tried to train everybody consistently. And if we had operators training operators, well, my minimum is your maximum. So whatever the best the trainer was or the operator was the best training the new operator got. So you can see over time how all that ended up being decline and decline and decline. So with Autodesk University, we can utilize all that to be able to make sure that our operators are as trained as to the best that they can. The ROI and the green light. So some of the different things that we looked at when we did the ROI for the investment on TruNest, We wanted to compare our current state and the gains from a change if we would implement TruNest. We wanted to be able to review the total support hours right now for implementation of one of our environments. We wanted to consider the opportunity of revenue loss. We wanted to calculate revenue loss due to scrap resulting from bad practices or processes. And we also wanted to look at part and project cost impacts based on reliable data. So to break that down a little bit more clarity, some of the different things you'll see to the right-hand side of your screen in the upper right-hand corner, you'll see where we looked at 5 of our different facilities, and we took the total number of parts in a single year that had to be manually tooled. We looked at that based on an average of 6 minutes per part from the tooling operator, how many hours that ended up resulting into, and then when we calculated that against their average hourly rate, you could see what the cost impacts were by division and overall for a single year. We wanted to do a comparison of what our current nesting software looked like versus TruNest. We wanted to be able to make sure that we weren't going backward, that we were only moving forward. Our current software today was very, very manual intensive. We were starting to see declines in the support from one of our vendors. Some of the needed functionality to bring ourselves into the next generation was not available for us. While we felt our software was good for nesting, it was only for smaller environments. As we scaled to larger environments, it's just not a fit for us anymore. We didn't have a unified approach. We talked about the fact that we have currently 3 different nesting softwares in our environment today. So to be able to support all those different ones and to be able to make any changes was threefold. And then obviously the amount of files that we had to manage brought on significant technical debt. Great thing about TruNest is they've been moving people from one of our main software for more than 15 years. So be able to know our current entire environment, the issues that we face and how we can best solve those right from the very beginning was huge. We knew that we could increase our manufacturing throughput by some of the different things that we can do with nesting today. One of those being the etching process, be able to do revision comparisons, and to be able to make sure that we were cutting the right revision the first time. Obviously, it was an impact or reduction for our waste. The online learning tool, the fact that it had its own standalone UI, and the fact that we could scale it globally were big. We wanted to be able to look at, from an error standpoint, what were those costs that we would see or that we would incur from a nesting standpoint. What that means is, how many times did I attempt to create a nest, or I ran across a nesting error because there was a tool that didn't get manually updated yet that failed when we changed a parameter? Or how many times did I attempt to do something and due to a file issue, we had to reset the nest and we had to restart again? So you can see there that all the different times we attempted to create a nest at all of our different facilities and how many times we didn't get a nest that we attempted to create. So when you take that and you look at the machine rate of what we should be outputting and you look at the total number of nests and total number of hours involved, it's a significant impact to our opportunity costs as a fabrication facility. One of the other things that we wanted to be able to share is, when it comes to support hours by IT and file corruption, some of the different things there. When we took a look at opportunity costs by machine, total number of parts per nest on average cost per part per nest, total parts per day, we could get to an hourly rate of what our machines would be if the machine was down. So if I had a machine down for 10 hours or 24 hours and it's $10,000 an hour in opportunity costs, in one day it could impact our company almost $250,000. As I shared earlier, I had 2 of those machines down for 2 days. So a 3-shift factory, 24 hours of potential runtime, $10,000 per hour per machine, $20,000 an hour for 48 hours. You do the math. The opportunity and the impacts for a file structure or a file corruption issue was huge. And then the other thing, the number of parts that we were scrapping based on wrong revision was unquantifiable. So our approach, we wanted to look at a number of different things. We wanted to be able to look at risk reduction. What was our current project demand? History of adoption to change success, machine post-development, part mix, current first pass rate success, network bandwidth, operator day-to-day production struggles, tool limitation, and biggest wins. So again, as we shared earlier, we wanted to be able to make sure we reduced risk. How can I keep my factories running with a new implementation and not impact production? We wanted to look at what is our project demand. Is one facility going to be a little slower right now than another? maybe that was going to be the best one to start at for implementation of our first go live for TruNest. We wanted to look at which facility have we had better success at adoption, getting those guys online, getting implement TruNest safely, done well, and running right out of the gate. We wanted to look at our part mixes. Some facilities run single product lines, some facilities run multiple product lines. So was there a way that we could get a good part mix that represented all facilities so that we could work through some of the things that we wanted to be able to do with TruNest? Our first pass success rates. We wanted to be able to calculate or average out having 65 to 84% first pass rate in our current software implementation of TruNest. How well did that increase right from the very beginning? Could I take 500 parts that I knew would process through our software today, run those through the AutoTran process for TruNest, and get 100% success rate for those 500 parts? The next thing I wanted to do is take 500 parts I knew errored through our auto batch processes today and wanted to run those through the AutoTran process. Just running those through with a new tooling software, some of the advanced logic that was available, how many things would I gain right from the very beginning, or how many points of percentage would I gain or increase right from the very beginning simply by implementing and not changing a single thing? We wanted to be able to look at some of the network bandwidth, some of the different things that we were dealing with some of our divisions with slow nesting processes. Back and forth between a file server, back and forth between the main server, some of the smaller machines we may have from a Microsoft perspective or from a PC perspective. How can we make sure that our day-to-day struggles and our network bandwidth were better just with implementation of TruNest? We looked at it from a local install of the client. We looked at it from a file install of the client, a file server install of the client, and we looked at it from a main server install of the client. We looked at tooling limitations. What did we struggle with today getting out of our current nesting software that we could gain with implementation of TruNest? Being able to punch chamfers on copper bar, being able to etch parts, whether it be a punch machine or whether it be a laser machine, and be able to move forward from there. And then obviously after execution, how can we continue to do improvement on the process that we put in place? For our first facility, we ended up choosing our Edmonton facility as our first stop and where we are with our current implementation. We had representation of the most typical processors needed for all divisions. So the machinery we had at our Edmonton facility pretty much represented what we had at all the other facilities, which was great. They only ran one shift, so it was great. We didn't impact all shifts with the new implementation. It was only one. Our current demand at this facility was a little bit lower than some of the other facilities, so from an impact standpoint, we felt it was better to go to Edmonton. Historically, Edmonton has always been a great place to adopt new processes and new systems. They've got that real go-to, can-do attitude of making anything work at any time. And their part mix at this division pretty much represented all their other divisions as well. So we knew going live at this facility with these machines would show us the way for how it would look for us to go to the other facilities as well. We have 5 different operators. We have 5 different machines. We have a few configuration changes, 1 shift, and 5 total different processors at the Edmonton facility. For the approach, we conducted several different site visits with the operators and supervisors to understand what their current process impacts were and what they needed out of a new nesting software. We did data extracts from our current nesting software on all post-processors that were represented. The tooling configuration evaluations and potential for change discussion, full life cycle process improvement, software, user role access development, NC code development and optimization, an ERP integration, client testing, required documentation creation, data reports, communication feedback loop, and logic, and then time gen. So to break down these in a little bit more detail, we met with each and every one of our operators and supervisors to truly understand what they dealt with from a software perspective. We allowed the Majestic team to hear it directly from them, what they needed to resolve with the implementation of TruNest. There was a lot of great communication back and forth through that. Because Majestic had worked for years of moving people from Optimation, we did a data extract of each and every one of our post processors to run them through the machines in the post to make sure that we were getting one for one, day one, all of our parts to be processed, all of our configurations and parameters were up to date based on what we've been tuning for years. We wanted to be able to make sure our lifecycle process was developed and implemented so that for the engineering published to shop floor fabrication, We wanted to be able to make sure we could process that all the way through and not lose any of the things that we have today. And if we did lose anything, it was only because we were implementing something better. We wanted to be able to make sure that all the roles were met for the different users on the shop floor. Some of our operators are a little bit more advanced and they can edit nests, edit material and things as we go. Some of our operators are just basic operators. We wanted our planners to be able to plan what they needed to do to make sure that we were running the latest material or the latest parts required for the projects that we have for that day. We wanted to be able to do some in-seed coded development optimization. The great thing is, while we were working on our ERP integration and also our engineering process integration, we were developing our posts, the NC code, and the optimization, which meant we were allowed to test some of the NC code in parallel without even having the UI in place. That way we could test the code, test the machine, test the language before we even did the full client testing. We wanted to make sure that we could get some documentation in place to make sure, from a technical perspective, or from a process flow perspective, everything for Powell that may not be included in Autodesk University was available for us. Data reports. We wanted to make sure that the data was there for us to collect the metrics that we do today, as well as started evaluating some of the different data that's going to be available to us to be able to make sure that we can continue to advance the metrics that we put in place. That feedback loop I shared with you with engineering, that was huge for us to be able to automate that right back to the engineer to provide them a PDF that showed them exactly where on the plot their error is and what that error was, so they could quickly and swiftly reprocess that part, republish it, and get it out to the shop floor if it was needed. Time gen. This is a game changer for us. As I mentioned, we're an engineer-to-order company. When it comes to managing capacity on our shop floors today, it can be a very difficult thing. When you average scheduling 3,500 parts at some of our facilities in a day's time, what does that 3,500 parts mean? Is it the size of your cell phone? Is it the size of your conference table? 3,500 parts could be 4 hours. 3,500 parts could be 5 days. With time gen, we can run through and within 2% of accuracy know exactly how long it's going to take us to process those 3,500 parts. Means we can bring in more. We could push out and smooth. Our on-time percentages for our first operation steps will get better. Our capacity planning for our shops to be able to understand whether we need to do overtime, whether we need to bring on an additional machine, additional shift, additional headcount. The time capacity was a big thing for us. So where are we today? The NC code has been evaluated on all of our machines and confirmed. The code that TruNest is putting out is exactly what our machines need and is running without error. The TruNest UI has been developed and deployed to our test environments. The ERP transactional integration is complete. Engineering published to TruNest processing is in its final stages. We're just tweaking a little bit about the UI and the plot to send back to the engineers for those error communications. We just started our UAT for the final stages of this project. Time gen is already in testing. So to be able to make sure from a capacity plan point, we will be ready to go from day one. Our go live for this entire project for the green light for prod, it will be 9/1 of this year. The unfortunate thing is we are a little bit behind schedule with that. We've had impacts from COVID just like everybody else has. That put a 4-month impact to us or a 4-month delay in this project. It is what it is, but the Majestic team and Powell have worked together to get it to where we are today, and we are ready for our go live. We're excited about that. For fiscal 21, this is what we plan to do. We're going to implement it at our North Canton and our Houston facilities. So that'll make us 3 facilities in a year and a half. We'll continue to do some of the advanced metrics development around tooling usage, part processing errors, things of that nature. We want to do automation of nesting creation by priority, updates to more efficient tooling configurations, enhancements to our UI for production impacts, and post-creation evaluation for our mills and saw operations at the Edmonton facility. So to break that down a little bit more, we want to continue to do advanced metrics around tooling usage and part processing errors. Is it the same error that we're seeing with our engineers? Is it something that we can look at for AutoCAD solutions, or maybe getting them some additional training to reduce the errors that we see from our engineering groups? One of the things that we want to be able to look at now that we have some additional metrics and reporting is what are the tools that we're using today? What are the percentages of those tools that we're using? Is it something that we can look at updating our current tooling configurations in our inventor blocks with our engineers to reduce the amount of tool changes and things that we may see that impact our throughput on our production today? We want to be able to make sure that our tooling configurations are as efficient as possible. Are we punching at the right time with the least amount of travel time or turret changes or things of that nature? Are we punching efficiently for the machine? As far as our UI goes, does everybody have all the information they need in front of them to be able to complete their job? Do we need to add additional information in front of our planners to be able to make better decisions on what we can do from a production standpoint that day? We also want to be able to make sure that we're creating nesting automatically. Take it out of the hands of the engineers to not even have to worry about creating the nest. Let the TruNest UI do it for you. We're planning to develop priority variables that will take into look at, is my part on time? Is it past due? Is it an urgent part that's needed? Is it a project that's prioritized? To be able to put all that in, TruNest will consume all that, calculate a priority for each work order that's in there, and nest what we need, when we need it, at the right time without anybody ever having to manually create a nest. And then again, we want to look at creating posts for our mills and saw operations that we don't have today. So to wrap up this conversation with you guys, we talked a little bit about who Powell is as a manufacturer, where our facilities are located, and the volume of our PLM. You saw our process flow of published parts, the metrics we defined, and the impacts of our projects and shop processes today. We provided insight into the various discussions held and the needs we defined, the requirements and the outcomes desired for the implementation of TruNest. We defined and shared our project ROI, some of those, the metrics defined and measured, and the expectations from our SLT. We identified the risk and reward, our phased approach, and methodically why we approached as we did with the best of our resources. And then we shared where we're at with our phased implementation and the roadmap to our success. And that concludes my segment for the Advanced Manufacturing Summit. Thank you for taking the time to join and listen in today. If you have any questions, feel free to reach me. Have a great day.